Yes, thank you. Can you go to the next slide because I don't seem to be able to do it myself. So thank you. So yes, my name is Alex. I'm here on behalf of the baby team at Merck KGaA, so the Darmstadt, Germany-based Merck. And yes, so we are the developers of Baby. So Baby is our open source software for Bayesian optimization, and you can access it on GitHub. We have a continuous development with 3 core developers from different areas at Merck, with 10 plus time to time developers. And although Baby is a tool that was originally built by the industry, namely by this core team, it is really built for everyone, and we wanted to make it available to everyone, which is why we decided to open source it in December 2023. And yes, Baby is a full framework package for Bayesian optimization. So it does not only offer active learning, which is probably the most interesting for the audience here, but also, given our background, we support a wide range of chemical encodings, we support hybrid optimization, we support transfer learning and single and multiple targets. And what we, for example, also support is bandit optimization, where you can efficiently find the best among many options in a noisy environment, where you can also see a visualization and the GIF there that should play. Hopefully, Jakob, can you click it? No, that brings us to the next slide. Okay, so there we have a GIF about bandit optimization. But if you want to know more about our recent features and what Baby has to offer, because I cannot go into detail here, please check out our homepage, check out the documentation, because there you can find all of the details about bandit optimization and also about our other recent development that I wanted to share here, which is on slot-based mixtures that you can see on the next slide. Where I want to spend a little bit more detail here, so because this is something that we think is really cool. So in the slot-based mixture representation, so coming from a chemistry background, there are basically different ways of how you can model a mixture. And the traditional mixture representation is that you have each of your different bases, solvents, phase agents, and so on. And you simply say, okay, I want to have 20% of this, 30% of that, 5% of that, which is rather easy to implement. But on the contrary side, you only list the amounts and the ingredient info is only implicit. But the slot-based representation, and this is something that we think that this could be a game changer, is that you have your experiment in different slots. So you have 3 slots, and you just think about what could you do in each of these individual slots. And this is something that a lot of people in our field have asked for, and which is a really, really cool feature. And unfortunately, you cannot probably see the link, but for everything I'm telling you, for everything that Baby has to offer, there is extensive documentation. So if anything of this is interesting for you, check it out, contact us, write an issue. We are very responsive. We are always happy to collaborate and talk with people. And we also have 2 questions that we want to bring to the community for today. So the first one is one that actually, echoing my colleagues here, comes from a transfer learning perspective, namely, how do we deal with nested or changing search spaces, respectively, how do we deal with very similar search spaces? Can we do something where? And also hybrid optimization, so continuous and discrete variables. What is the way to go there? How do we actually approach that, and how should you approach that? And that's all from my side.